In an Aerospike database, each namespace has the ability to be configured one of two ways, prioritizing availability or consistency. To better understand the differences between these two configurations, we need to take a moment and explore the Cap Theorem. This theorem states that in a distributed system, one can only choose two of the following three guarantees at a certain point in time. Consistency: every read request returns the last successful write, or an error. Availability: every request always receives a response without the guarantee the data is current. And partition tolerance, ensuring a cluster's ability to continue working during lost or delayed communication between nodes. In a distributed database, network faults are unavoidable, even more so in cloud environments, so partition tolerance is always necessary, leaving us with the choice between two options: availability or consistency. In the AP mode, which is the default configuration, Aerospike favors availability, allowing node failures and network partitioning while still attempting to provide data as consistently as possible. Aerospike achieves this durability and availability through its ability to automatically replicate data throughout a cluster, storing multiple copies of every record. The replication factor, configured on a per namespace basis, is most commonly set to maintain 2 copies, but can be set anywhere between 1 and the number of nodes used for the namespace. In availability mode, when a cluster is healthy, reads pull from a single replica, generally the master copy, and write transactions are replicated across the cluster, providing consistency between all copies of a record, every transaction. When network partitions occur, the self-managing cluster rebalances and migrates data while reads continue to pull from available replicas and writes are replicated across all available replicas for the partition. This allows Aerospike to guarantee availability while still providing the maximum level of correctness, though strong consistency is not guaranteed. In strong consistency mode, Aerospike guarantees consistency, accepting some unavailability during network failures, outages, and partitions. To begin, a cluster needs a defined list of nodes, known as the roster. When the roster nodes are available and partitions are current, the cluster is healthy, providing optimal availability. In situations where a two-way split occurs, creating exactly 2 subclusters, as long as the client can see all the nodes, all partitions are available for reads and writes in one or the other subcluster, providing 100% availability of strongly consistent data. The roster only allows for one active partition, avoiding conflicts with duplicate records and data loss. When network faults and node failures occur, Aerospike will do its best to make data available, without sacrificing strong consistency. The strong consistency guarantee is per record, with each record's write being atomic and isolated. The client receives acknowledgement of success only after all replicas have been updated, ensuring that when a record is committed, it will be observable by all readers. By default, client read requests are always sent to the master partition. Situations may occur where multiple nodes temporarily think they are master for a partition, such as a node splitting from the cluster. Only one master is able to process a write, so to identify which is the correct master, Aerospike uses a cluster regime. The regime is a value updated every time a recluster event occurs that identifies where the data is active. Verifying the master belongs to the latest regime avoids write conflicts and ensures the strong consistency guarantee, even during cluster changes.